Hey Year 11s, hello, it's David here. You can't see me, but I'm going to try and teach you guys through the medium of video. Let's see how this goes. Experiment number 1. Alright, lesson 3, operations on fractions. I'll read it out and you can read in your workbooks in front of you because you obviously can't read the writing on the screen. Operations on fractions observe the same order as operations on integers, in other words, bed mass. But there are a few peculiarities with fractions, one of them being you can only add and subtract fractions with the same denominator. Now, why is that? Well, if we have, say, a half plus a third, that's like a half plus a third. And we can't really do anything with that. It's a half plus a third. I mean, they're unlike terms. Annoying. Let's instead change that to 3/6 and 2/6. So we have circles cut up into sixths, and we're going to cover in half. So 3 of them. And we've got a circle cut up into sixths. We're going to color in 2 of them. Same thing. 1/2, 1/3. But now 3/6 and 2/6, we can do that. That's 5/6. So whenever we're adding and subtracting, we need to make sure we have the same denominator, the same bottom number. So addition and subtraction, we need the same denominator, the same bottom number. Let's talk about multiplication now. Let's recap integer multiplication. What was -5 times 3? Here we did, we had, like, these are -1 tiles. We had 5 of them. And we did that 3 times. Yes, I will be bothered to draw out all 15 of them. Ha! And you have to watch me do it. And you can't fast forward. Sucks to be you. Right, so 3 lots of -5 is -15. Okay, what about 3 times 3? That's the same as having a rectangle that's 3 down and 3 across, giving us 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. What about 3 times 4? That's like a rectangle that's 3 down, 4 across. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Cool. Now let's do fraction multiplication. Let's do, let's write it here. 2/3 times 4/5. Now what I'll do is I'll show you the rule, the thing that you can memorize and it will serve you well. And then I'll show you why that rule is the way it works. The reason why is confused. It's harder to understand than the rule. So if you want to just learn the rule, feel free. If you want to learn the rule and why it works, also feel free. The rule is you multiply the top numbers together and you multiply the bottom numbers together. So for example, 2/3 times 4/5 is 2 times 4 on the top, 8, and then 3 times 5 on the bottom, 15. Calculator, what do we got? We got 2/3 times 4/5, which gives us 8/15. Yay! So that's the rule. Times the top 2 numbers and times the bottom 2 numbers. So, or you could think of it like this. If we have a rectangle that's 2/3 down, what does that mean? So here we had a rectangle that was 3 down and 3 down here. What does it mean to have a rectangle that's 2/3 down? I could think of it like this. I could think of it in terms of 3 down, but then only colour in... Ooh, look, colour pencils. Ha, life is good when you bring in colour pencils. But only colour in 2 of the squares as I go across, showing that in total it's 3 down, but I've only got 2/3. Let's write that in. So we've got 2/3, but how wide do we make this? Along the top we've got 4/5. So I'm gonna go 5 across. And I'm only gonna colour in 4 of them. But first, I'll finish colouring the 2/3. 2/3, 2/3. Colouring in 2/3. Right, so I've got 2/3 of this rectangle. But now I want to take 4/5 of this side. Let's find another colour. Ta-da! Green. 4/5. So 1, 2, 3, 4. I'm going to colour in the whole thing here. That's 2. Sorry, when I say the whole thing, I mean the whole way down. Okay, and what I want to know is how many squares are shaded in both colours. As in how many squares are part of the 2/3 and part of the 4/5. 1, 2, 3, 4, 5, 6, 7, 8. And how many squares do I have in total? Hopefully you can see where we're going here. We've got 5 times 3 is 15. Ta-da! That's how that works. What about 1 1/2 times 3/7? Well, that's nasty because the 1 1/2. Let's talk about the rule first, what you would do, and then let's talk about why. 1 1/2 times 3/7. Now what you want to do is you want to multiply the top numbers together and multiply the bottom numbers together, but there's this awful great ugly 1 sitting in front. What do you do with that? To deal with that 1 1/2, we want to turn it into an improper fraction. So for example, how many halves are in 1 1/2? I have a whole, I have a half, but that's just 2 halves. So I could think of 1 1/2 as 3 halves, which makes our life much easier. 3 halves times 3/7. Let's multiply the top 2 numbers, getting 9, and the bottom 2 numbers, getting 14. Alright, let's try that out. 1 1/2 times, what do we say? 3/7. Hopefully it should be 9/14. Yay! Okay, so somehow we should do this sort of thing and get 9/14. Again, if you're happy remembering that rule, then by all means, go for it. But if you'd rather know how it works, then listen up. 3 halves, or 1 1/2, this is going to be confusing to draw. Let's start by, rather than doing 1 1/2, let's do just 1 for now. I'm doing 1 2 units down for good reason, as you're about to find out. I want to do 1/2 being 1 unit long, so to scale it all up, 1 unit is now 2 long. Just on the vertical side. Horizontally we can still be, 1 for 1. But I'm going to do this in a dotted line. I want to go 3/7 across. I want to draw 7 boxes, well, a rectangle 7 across, but only shade in 3 of them. 3, 4, 5, 6, 7. And again, I'll do that in a special dotted box, and I'll explain why in a second. I'm going to explain why I've done this box dotted rather than was it the word solid, like this one, because I want to colour in 1 1/2 of this side, which is actually all of it. but notice I still haven't answered the question. Why is this second rectangle dotted? It's because it doesn't count towards the total. If I wanted to ask how many green squares there are, there's, 1, 2, 3, 4, 5, 6, 7, so there's 14, so there's 21. But out of how many? How many total squares do we have? This here is like a bonus. It's like an extra. It doesn't count towards the total. So we've got 21 out of 14 shaded. And that doesn't make much sense. We've got more shaded than we have in total. What? But actually, we're dealing with 1 and 1/2, or 3 halves. So we do want more squares shaded than we actually have in total. So in a weird way, this makes sense, but I'll admit it's in a very weird way. Now we want to colour in 3/7 of this one. So we do have 7 across. We want to colour in 3 of them. Hang on, do we colour in these ones here? Good question. Yeah we do. Man, so yeah, this is more complicated for me than just learning the rule. But hey, if you want to know how this works, great. Now, how many squares are coloured in twice? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 coloured in. And what's our total? Remember that this doesn't count towards our total. This is bonus. This is extra. In fact, I'll write underneath it. Bonus. Extra. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. In total. These ones don't count. 9/14. Exactly what we were expecting to get. So that's the rule for multiplications with fractions like that. And this is actually, it's still the same rule when you've got funny fractions like 1 and 1/2. You just need to change it so that 1 and 1/2 becomes 3 halves, for example. Is there anything else you need to know about multiplication? Nah, that's it. On the next page, we talk about division, which we won't talk about today. This will be another day. In the meantime, you have questions here on addition and subtraction, remembering to put them all to the same denominator. You have questions on multiplication and questions on division. Don't do those because we haven't talked about them. Don't do them. Do as many as you need to feel like you get the idea. You may not need to do all 15. You may need to. It's really up to you. For these ones with multiplication, feel free to just do the rule, like 4 times 4 and 6 times 12 is 16 over 72. That will simplify down actually. It's 16 over 72. I'll do some work in the margins. 16 over 72. Divide both sides by 2. That's 8 over 36. Yeah. I can still divide the top and the bottom by 2, giving me 4 over 18. And I can divide both sides again, giving me 2 over 9. Apparently that's 2 over 9. I will double check that, because it's late. And it's okay to check your answers. 4 over 12. 2 over 9. Cool. Please give your answer in the simplest form. Please don't give it in the biggest form or anything in between. Simplest form is where it's at. Do as many multiplication questions as you need to feel like you get it. Division, we'll talk about another day. Enjoy class. I'll see you around the place on Wednesday, Thursday, Friday. Have a good day. I'll see you guys later.